Hello everyone. Today we'll go over Chapter 9.1, Solving Linear Equations by Substitution Part 1. Example 1. A 60-meter cable is cut into two pieces. One piece is twice as long as the other piece. Determine the length of each piece of cable. So we're trying to find the length of each cable. First thing we need to know is that the longer piece is twice as long as a shorter piece. So for the longer one, long piece, I'll label it as L for the variable. And S for short piece. We first need to set up two equations before we can solve these two variables. And the first one will come from the first statement here. We know that 60-meter cable is cut into two pieces. So we can say that the sum of those two pieces equal to 60. So L plus S equals 60. Equation 2 comes from the second sentence here. So one piece is twice as long as the other piece. Well, whatever that's longer has to be, so L has to be twice as long as the short piece. So we came up with two equations. The question asks us to solve it graphically and by using substitution. Let's take a look at the graphical way first. We first need to set up the grid. I'll do 0. It goes up by 10. Actually it goes up by 5, so I'm just going to increment every 10s. All the way up to 60, because 60 is the maximum length we can get. Same with here. I'll label short piece as the independent variable and longer piece to be the dependent variable. So from the two equations we had before, L plus S equals 60. You might not see exactly how to graph this right away, so I would strongly suggest you using a table of values. So let's create two table of values. And because we set up our grid as S as an independent variable, so we're going to put S to L. So independent variable comes in the left column, and the dependent variable comes on the right column. So let's just pick a couple numbers, like when S equals 0, 10, 20, and 30. Let's see how this goes. And same thing with, this is equation 1, and this is equation 2. So 0, 10, 20, and 30. All right, let's take a look. For equation 1, L plus S equals 60. So if S is 0, L is 60. And then it goes down by 10 every time. So 50, 40, and 30. And for the equation 2, when S is 0, L is 0. When S is 10, L is 20, and then 40, and then 60. All right, so let's try graphing it. I'm going to graph the equation 1 in blue. So we're starting at S is 0, L is 60 right here, 10 and 50, 20 and 40, 30 and 30. So let's connect those points now. Okay. All right, so we should end here at 60 because when L is 0, then S should be 60. So this is equation 1. You do not need an arrow because it's not continuing more from this point. It doesn't work this way, so you don't have to write any endpoint arrows here. In red, I'm going to graph the equation 2. We're starting at the origin, 0, 0, 10, 20, 20, 40. I see the intersection here already. And 30 and 60. Where's my 30? Right here. So I'll just connect those points as well. Oops. And this time it shouldn't really go above that. But that's okay, we'll just leave it there. Equation 2. Our intersection happens right here. And the coordinate is 20 and 40. Okay, so we solved the system graphically. We do have to state here, so from the graph, solution is 20 and 40 right here. And we also have verified it right here, so 20, 40, and they're both common in each table values. So we can say verified using table values. And now for part B, we're going to solve the system using substitution. Alright, so let's first write down the two equations so I can see it. So equation 1 is L plus S equals 60. Equation 2 is L equals 2 times S. So notice that equation 2 already has L isolated. So using the substitution method, we could actually just sub in the equation 2 into equation 1. So let's start with equation 1 here. We'll first state it, and you're going to sub in this value, this expression, into this L. So we can say 2S plus S equals 60. Okay, so now you collect the like terms. We did this in polynomial unit, so whatever you see here, common variable, you just collect them together, all the coefficients. So it'd be 3S equals 60. And you divide both sides by 3 to isolate S. You get S equals 20. So once you find one variable, then you can actually sub it back into one of the two equations we set up. I would choose equation 2 because we're looking for L and it's already isolated. So I'm just going to sub this in here, this in here. So S equals 20, so 20 goes into here. 2 times 20 equals L. So L is 40. And then we can say solution set is, depending on what you set as an independent variable, but let's stick to the same way, 20 and 40. But because the situation we have for this question was actual real life situation, so we do have to include the units and what they represent, what the variables represent. So we can say the long piece is 40 meters long, and the short piece is 20 meters long. So that's it for example 1. For example 2, solve the system of 2 given equations. Okay, so we'll solve it graphically first. So we first need to write these 2 equations into y equals mx plus b form, which is a slope-intercept form. So let's rewrite that. X plus 3y equals 9. We're going to isolate y, so let's take away x from both sides. So we are left with 3y equals negative x plus 9. And we do need to divide the entire equation by 3. So we get y equals negative 1 over 3x plus 3. So this is our equation 1. For equation 2, we do the same thing. We'll isolate y, but in this case, notice that this is a negative y. So if I move the y to the other side, it might be better. So 4x equals y plus 10 minus 10 on both sides. We get, then we get, y equals 4x minus 10. So I'll just rewrite it this way. Alright, so this is our second equation. Let's graph it. Equation 1, I'm first going to set up our grid. Pardon this small grid here, but we'll just label it. The increments 4, 6, 8, and 10. Same as for the y values as well. It goes up by 2. Alright, so first equation 1, intercept is 3. Y-intercept is at 3. And then it goes down 1 and goes 3 to the right. 1 down, 3 to the right. 1 down, 3 to the right. And 1 down, 3 to the right. So it should be x-intercept is at 9. I'm going to connect those points. Oh, okay, that's good. That's pretty good. Okay, so this is equation 1. And let's take a look at equation 2. Y-intercept is at 10. It goes, is it at 10? Oh, minus 10. Minus 10. Okay, so not just 10. Right here. Minus 10. And it goes up by 4. And then 1 to the right. Up by 4. 1 to the right. And so on. Just like that. And you connect the points. And we could see that there's an intersection right here. And this is the solution set is 3 and 2. Solution set. Now let's take a look at this using substitution. Alright, so for equation 1, we have x plus 3y equals 9. And equation 2, for x minus y equals 10. Before we can use substitution, we need to isolate one of the variables. So I'm just going to rewrite the first equation. So it's x is isolated. X equals. So we're going to remove 3y from both sides. So 9 minus 3y. Right. Oh, you know what? I kind of like the coefficient better. Negative 3y plus 9. Okay, so I'm just going to sub this x expression into the second equation x. So we can rewrite 4 times negative 3y plus 9 minus 9 equals 10. All right, and then we're going to expand. Make sure to expand it to both terms. It's boiling, by the way, so negative 12y plus 36, and then minus y equals 10. You collect the like terms together, which is negative 12 and negative 1, so it's negative 13y plus 36 equals 10. Remove 36 from the left-hand side and the right-hand side, so we are left with negative 13y equals negative 26. And then lastly, we're going to divide out negative 13. So we're left with y equals 2. Okay, so once we solved for one variable, we can actually just sub this value into one of the other equations. So let's see, this time we're looking for x, and because we have y, we're going to plug it back into the first equation we found. So sub into x equals negative 3y plus 9. This 2 goes in right here. So x is negative 3 times 2 plus 9. So we get x equals 3. So the solution set is 3 and 2. And we have verified it in 2 different ways. All right, moving on to example 3. Solve each of the following systems using substitution. So looking at these 2 equations, we can actually first isolate one of the variables, and I'm going to isolate x. So let's add 2y to both sides. So we're having x on the left-hand side, 2y minus 2 on the right-hand side. So this is equation 1. And we're going to plug this, sub this into the x value here. So let's take a look. We have 3 times 2y minus 2. And then we continue with the rest of the equation. Minus y equals 4. Expand where you need to. We have 6y minus 6. You bring down the rest of the equation. You collect the like terms. So we have 6 and negative 1, y. So then we can say negative positive 5y minus 6 equals 4. And then you remove negative 6. 5y is on the left-hand side now. We are left with 10 on the right-hand side. You divide both sides by 5. You're left with y on the left-hand side and 2 on the right-hand side. So y equals 2. You sub this back into one of the equations. Preferably, I like this one. I like this one because we're looking for x now. We just need to plug in y into here. So x equals 2 times 2 minus 2. So 4 minus 2, x equals 2. So solution set is 2 and 2. Moving on to part B. Same step. We're going to isolate x from the first equation. So let's remove 6y from both sides. So we're left with x equals negative 6y minus 29 first. We're going to sub this expression into the x on the second equation. So we have negative 6y minus 29 plus 1 over 4y equals negative 6. All right, so this time we don't have to expand anything, so I'm just going to get rid of the bracket. And then collect the like terms. But if you're not familiar with adding numbers, like a whole number with a fraction, I would strongly suggest you multiply the entire equation by the denominator of the coefficient, 4. If you do that, you get negative 24y minus 29 times 4 is 116 plus y equals negative 24. And then you're going to collect the like terms. There's negative 24y and positive y, so I'm just going to say negative 23y minus 116 equals negative 24. Let's add 116 to both sides. We're left with negative 23y equals 92. And then we're going to divide entire equation by negative 23. We're left with y equals negative 4. We now sub this back into this equation to find x. So x equals negative 6 times negative 4 minus 29. So negative, or not negative, positive 24 minus 29, which is negative 5. Our solution set is negative 5 and negative 4. We have a solution set, which means we have one solution, and the solution that yields a definite result, as in some coordinate or solution set, then we consider the system an independent system. Let's try part C. So same step, we're going to isolate x from the first equation by taking away 3y on both sides. So I'm going to skip some steps. Negative 3y plus 3. And I'm going to sub this expression into the x here. So we have 3 times negative 3y plus 3. And then you write the rest of the equation. Expand where you have to. We get negative 9y plus 9 plus 9y equals 9. Collect the like terms. So notice that we have negative 9y plus 9y, and you take away 9 on both sides, so you get 0 on the right hand side. And this gives us 0 equals 0. Okay, so right away, this is when we can state that there are infinitely many solutions. So this identity happens when two equations are overlapping on top of each other, which means it's a multiple of the other equation. So we can actually see that the second equation is a multiple of 3 of the first equation. So if you multiply 3 to equation 1, you get equation 2. Therefore, these equations are overlapping, and that tells us that there are infinite solutions. And this indicates that the system is dependent. For part D, I'll isolate y this time from the second equation. So y equals 2x plus 1. And I'm going to sub this value into the y value here. So we have 2x minus 2x plus 1 equals negative 13. And make sure when you see a negative in front of the bracket like this, you do have to expand it into the bracket, okay? So we get 2x minus 2 minus 1 equals negative 13. Okay, it's a very common mistake there. And we're going to collect the like terms. So we're going to add 1 to both sides. We get 0, actually, hold up. We get negative 12 on the right hand side, but notice we have 2x minus 2x, which results in 0. 0 equals negative 12. That doesn't sound right. So this is when we can say that there is no solution to this linear system. So when systems that yield a false result, such as 0 equals negative 12, then this is called inconsistent system. Okay, so the equation of an inconsistent system yield parallel lines. So they'll not have any intersection, therefore there's no solution. So that's it for today. I'll see you guys in the next video.